Welcome back. After that 17-minute video you may have just watched, I wasn't sure you're all going to make it back, but I'm glad you made it back. So we're going to continue on with the first week of this course. First I'm going to kind of recap what happened last time in the last video. I talked about some basic concepts. One of those is systems, right? A system is a collection of components that function together to accomplish some type of task. Then I can specialize that little bit to an information system. In an information system, the components involve hardware, software, people, data, and processes. And the input to an information system is data, and the output from an information system is information. So there's this difference between data and information. And data is basically a fact, a number, a character, a graphic. It has no inherent meaning. But when you put a context to that data, it becomes information. Higher up the level of hierarchy are the terms knowledge and wisdom. But the information system is going to focus primarily on inputting data and transforming that data into information. So we know what an information system is. Well, a geographic information system is going to do the same thing as an information system, but what it's going to do is it's going to convert geographic or spatial data into geographic or spatial information. Then I talked a little bit about models. Remember, models are simplifications and generalizations of some portion of reality. So it's an abstraction of reality, a simplification, a generalization. So now I can move on. What kind of models does a GIS use to represent spatial data? So GIS, spatial data, spatial information, what kind of model, simplification, and representation is this GIS going to use? Well, there's two basic types. The first type is called the vector data model. I'm going to talk about that one in this video, and then in the next video I'll talk a little bit more about the raster data model. So those are the two basic models that GIS uses. So what's a vector data model? A vector data model is a type of model that simplifies and generalizes, right? That's the same thing as a model, real entities into one of three basic types of objects: points, lines, or areas. And sometimes areas will be called polygons. I'd like to call them polygons. Some folks call those areas. So a vector data model says whatever piece of reality I'm simplifying and generalizing, I'm going to consider it to be made up of points, lines, and or polygons. This raster data model is another way of representing and simplifying reality. The raster data model says I'm going to represent reality by a grid structure that has regularly spaced cells. Those cells are usually square, but they need to be rectangular, they need to be regularly spaced, but they can be square. It makes it easier to process if they're square. So this, in theory, could be some type of a depiction of reality. It's actually an image of reality. It's an aerial image of reality. And the raster model is going to convert that into a grid of cells. So you can see that the blue cells appear to be representing that water portion of reality. Maybe the red cells are representing some portion of a transportation network. So the grid is going to say reality is made up of cells. And you'll notice that each cell has one color, and that cell is going to have one value in the raster model. Here's another raster model. This is an image, and that's what an image is. It's a model of reality. And so this is an image of an aerial photo of the Colfax area on the Palouse. I think this is the same photo I showed for the description of abstraction. So this is an image, a raster data model. I might be interested only in the stream network, and so I can use a vector data model to represent the streams that are flowing in that area using lines or polylines. So a vector data model of the stream network in this area would be lines. What if I'm interested in transportation network? Well, here the black shows a vector data model representation of the transportation network. Again, it's showing those as lines. What if I were interested in Colfax itself? I could represent Colfax as a polygon, and this polygon actually represents the city limits of the town of Colfax. So I can represent Colfax, Washington as a polygon. So you can see how the vector data model can represent reality using lines or polygons. But how about if it wants to represent something as a point? Well, consider if you were interested in Colfax, but only in terms of generally where it's at. Maybe you need to stop and get gas or stop and get something to eat. You don't really need to know all about what the city limits of Colfax are. So you might decide, I'm going to represent Colfax as a point. My model will represent the town of Colfax as a point in space, and that's what that red point is. And that's an example of what's called generalization. I'll talk a little bit about that more in the course. But your model of reality gets to choose which aspects and at what level of generalization you're going to model reality. Okay, so here's a vector data model. It's got Colfax, the transportation network, and the stream network. Those are the portions of reality that I want to model using my vector data model. Okay, so before I said that a vector model simplifies and generalizes into points, lines, and polygons. Usually the vector model is better used to represent things that are discrete features. They're specific inside or outside. They are or they aren't. There's a clean-cut boundary between a vector feature and an adjacent vector feature or other vector features. So points. What is a point? A point is a zero-dimensional object characterized by a location in space. Okay, well, what is a zero-dimensional object? Those of you that see that x and y axis down there are going to say, well, it's not a zero-dimensional object, it's a two-dimensional object. But it really isn't when you consider the word dimension to be a measure of an object. And so when I ask you how big is that point, you're not going to be able to tell me how big it is. So it has zero dimensions. A point is a zero-dimensional object. The way you specify location, I'll talk a lot about that in the videos that follow on the next week or two, is you generally specify coordinates of some sort, and in many cases Cartesian coordinates are what it's chosen, which is an x and a y component. Okay, a line. Sometimes a line is known as a polyline in some GISs. A line is a one-dimensional object, right? It has a measure, and that measure is the length of the line, characterized by its location in space of all the points that are on the line. So you can see it has beginning point, an end point, and it has internal points. So a polyline can be made up of many line segments. Each of the line segments is connected to the other line segments. And when we get into terminology, the endpoints of the polyline are considered nodes, and the internal points of the polyline are considered vertices. What's an area? An area has two dimensions. It has area, that's a measure of the size of an area, and it also has perimeter, how far it is around that polygon. And it's characterized, again, by connected lines. Remember, lines are made of connected points. But for a polygon, the starting point of the first line is identical to the ending point of the last line. So a polygon closes on itself. It has closure. So next time I'll talk a little bit about the raster data model. That was a quick fly-through of the vector data model, and I hope you got the basics out of those things. Vector, three basic things: points, lines, polygons; raster, grids and cells. Thanks for watching.